All right, cluster students, let's talk about subtracting rational expressions. So again, the same thing we need, we have to make sure that the denominators are the same. And here in this case, they are. So the only thing we need to do really is to go ahead and subtract them. Now, we have to be worried about the minus sign. So the simplest way to do that is think about the minus sign as a negative, and you're going to have to change the numerator of what you are subtracting. So let's look at it. So I'm going to change that minus sign to a plus sign and then turn it to a -1. And notice that I put parentheses around the binomial, the x plus 3, because I got to make sure that the signs change for all terms in that numerator. So that's the biggest thing. That's the difference. So I'm going to do 3x plus 7 minus x minus 3, combine like terms, and I get 2x plus 4 over x squared minus 4. And you're like, okay, I'm good, I'm done. Again, if you can factor your numerator, go ahead and do it, because you may see that you can simplify it some more. And remember, these problems say in the simplest form. So you have to keep simplifying. So right there, you wouldn't get all the credit because you haven't simplified enough. So let's go ahead and factor the numerator. So if I look at the numerator, it shares a 2. So if I factor a 2 out, my binomial is going to be 2 times x plus 2. And so there's my numerator. So if I'm factoring out my numerator, I got to factor out my denominator. So we know that that's difference of squares. And at this point, you should be able to see a difference of squares like immediately and know immediately what they are. So I know what it is. So therefore, let's go ahead and write that out. And let's simplify the x plus 2 over x plus 2. So that turns into 1. And so that is my answer, 2 over x minus 2. So we'll leave that as an answer. All right, so let's go to B. All right, so now we don't have denominators that are the same. So we want to do that first. So that 4x squared minus 1, you should recognize it. That should be difference of squares. So we know that should turn into 2x minus 1 times 2x plus 1. That is what that should turn into. So then the 10x plus 5, what is shared there? I hope you say it's a 5. So you know that would be 5, 2x plus 1, which is what I'm hoping. So now let's go ahead and change our denominators. All right, so we're good there. And so I'm going to erase the work that I just did. Now, also, I did 2 steps. I factored, and notice what happened to the 2. And notice what happens to the minus sign. So again, that minus sign needs to be turned into a negative, and I can just combine like terms. And since 2 is the only term that's in my numerator, I can just make it a -2, and we can move on. Now, let's go back. We have to have the same denominators, and by far, this is not the same denominator. So let's talk about it. So I have 2x minus 1 and 2x plus 1 in the left. Then I have 5 and 2x plus 1. And remember, we have to share all the different factors together. They have to, each different factor has to be represented to its highest exponent. So in the left one, the only thing I need is a 5. That is it. I need a 5. But in the right one, the only thing what I need is a 2x minus 1. And so there you go. So our denominators look great. They look like they will be the same. And so let's start simplifying my numerator. So that 5 times that x minus 3 should turn into 5x. Oh, I'm still on eraser. 5x and 5 times -3, which is -15. And then on this side, that -2 times 2x and times that -2 times 2x is a -4x, and -2 times -1 is a +2. So there you go. You have both groups, and I've combined it as one fraction, one rational expression. So I'm going to leave my denominators alone, but let's see if we can simplify the numerator. So 5x minus 4x gives me an x, and a negative 5 plus a 2 should give me a negative 13. And there is no factor in there that needs to be done. That numerator is done. And so there's no terms to simplify. So that is my answer. All right, so let's go to. All right, so again, let's go ahead and factor. And we're going to take that minus sign and change it to that 6. So let's go ahead and factor the x squared minus 4. So we know that's difference of squared. That one's easy. Let's go ahead and make our little factor diagram. So I'm going to put negative 20 here, and I'm going to get positive 8 right there. What two numbers multiply to give me negative 20, but add up to 8? I hope you say 10 and 2. So I need a positive 10 because that 8 is positive, and a negative 2. As always, factoring is so important. So let's go ahead and rewrite our two fractions. All right, so pause here to make sure you understand what happened. Minus sign is gone. So look at that, what that became, and look what you became. So just make sure you recognize that. Now let's look at our denominators. Our denominators are not the same. So let's figure out what each one needs to become a common denominator. So on my left, I have x minus 2 and x plus 2. But over there on my right, I have an x minus 2 already. But my right has an x plus 10. So that obviously is what needs to be added to my left term. All right, so that's taken care of. Now to my right term, what third binomial is missing in my right fraction? Yeah, that x plus 2. So if I look at it, each of my fractions will have the 3 binomials or the 3 factors to make the common denominator. So let's multiply this baby out. So just remember, you have to do x times x and 10 times x. That negative 6 has to go negative 6 times x and negative 6 times 2. So let me go ahead and erase our nice little factor tree. Okay, and let's figure out. All right, so here is the left, the x squared plus 10x, and here's the right, negative 6x minus 12. So let's combine those terms. So I get x squared plus 4x minus 12. But if I look at that, if I can factor the numerator, I have to factor. So let's go ahead and draw our tree. So we have negative 12 and we have a 4. What two numbers multiply to give me negative 12, but add up to 4? I hope you say 6 and a negative 2. So let's replace those, x plus 6 and x minus 2. So far so good. But if you notice something, yes, I can simplify. It's why you always have to factor your numerator if you can, to see if you can continue to simplify. And so there you go. There's no more simplifying in that. And that, my dear friends, is our beautiful answer. All right, so let's go to the next one. This is going to be our last one. I believe our last one. So let's go ahead and factor it. Also, please change that minus sign. So here we go. We have 4 and 5. What multiplies give me 4, but add up to 5. 1 and 4. And then over here, we have 32 and 12. What two numbers multiply to give me 32, but add up to 12? Hope we say 8 and 4. All right, let's make our parentheses and change that minus sign to a negative. So there we go. That's pretty good. So I'm going to erase because it's going to get in the way of what we need. All right, so what do we need for the left rational expression? So what do we need for the left fraction? So I have an x plus 1 and x plus 4, and over there there's an x plus 8 and x plus 4. So obviously the left needs an x plus 8. So what does the right need? X plus 1. And now they look the same. Now it's time for multiplying. So again, let's look over here in our little corner and see us multiplying the x plus 8 and the x minus 2 out. So we have those first terms, outside, inside, and our last terms. And we're going to simplify those to x squared plus 16. So the multiplication of that is going to go here. Let's go to the other side, our right fraction. And that's easy. Negative 8 times x, negative 8 times 1, we get negative 8. All right, so let's just replace everything. So that went here, and then that went here. And so now all we have to do is combine like terms. X squared minus 2x minus 24. There we go. Now, obviously, if I gave you more space, that numerator can be factored. And this is what makes this the last problem. It was two long videos. I apologize. So here we go. So we have negative 24 up here. We have negative 2 down here. So what two numbers multiply to give me negative 24 but add up to a negative 2? 6 and 4. So I need a negative 6 because that 2 is negative, and I need a positive 4. So we go ahead and write it, and then what do you notice? I see x plus 4 and x plus 4 in numerator and in the denominator. We can do that, and there we go. We have our answer. All right, so there you go. That is the last problem we have to do. That was subtracting. So therefore, adding, subtracting, you have a short assignment. I think it's either 8 or 9 problems to practice. It will not be due till next Tuesday. Just please keep up with your work. Remember, this is second. You're missing the entire second semester. I'm trying to give you as much as I can, but it is not going to be enough. The other kids would have learned something that you haven't. So you got to keep going with it, keep trying, keep teaching yourself. So when you get in pre-cal, you won't be too far behind. I hope to see you in the Zoom meeting today for all the help that you may need. I probably have 2 of them in a row for you guys. Again, I am through with statistics because seniors are done. So I hope to see you guys in the Zoom. I'll talk to you later. Bye.